Okay, so now let's talk about the optics of laser beams. And here, what you see is you see the two mirror resonators for all cases, but the first resonator has two flat mirrors over here, and this region is the amplifier region. This yellow part is representing the amplifier, the medium that the laser gets amplified. So in the first case, we see a optical resonator which consists of two mirrors, and of course together with the amplifier it makes up the laser. So for this kind of laser, the produced shape of the produced beam is just a parallel. I mean, it's called, what you see over the shaded area is just the shape of the laser beam, and it's just the collimated. And as the laser gets out of this resonator from the second mirror that has some transmission probability through it, so this is the output of the laser. What we see is the output, of course. So inside there is some larger intensity in compared to the output coupling the light up after the coupling mirror, and usually the shape is not modified at all after the laser leaves the second mirror because it's already collimated. But this is not all the resonators or optical resonators using this kind of two flat mirrors. Sometimes what we see is this: one of these mirrors are not flat; it's with like these curved mirrors. Okay, so if you have one of the mirrors curved like this, what you will have as the shape of the laser light inside this resonator will look like this. Okay, it's kind of it's kind of getting focused at some point, and in this picture, the laser intensity gets focused and the intensity gets higher and higher, and right at this second mirror, and through this mirror it gets out, because this point is the smallest diameter or the spot size of the laser. After this point, what happens is that the laser light is again getting diverged from this and getting like a diverge going out. So I mean, in this case, the output of the laser obviously is not collimated. It's not parallel. But this is not the problem. We always have something to fix after this. Having this shape of unparalleled laser light, we can put some lens system and to correct this. I will talk about this in the second slide. So as I said, the shape of the mirror is not specific to this kind. Also, we might have also this kind of shape. I mean, this kind of mirrors, both of them just curved mirrors and looking like this. Two curved mirrors are like facing each other, and in that case, what we have, again, the shape of the laser beam is not parallel, or it's not collimated, and it will look like this. At some point it will have the smallest spot size, but after this point it will diverge. But we say that particularly to this smallest spot region as the waist of the laser. Okay, this is called the waist. The waist is here in this second picture, but in the third picture, there is no waist in the first picture because all part of the laser is parallel. So this is the waist. And why, if you ask why some system prefer to this kind of resonator having two mirrors, just not flat but they're curved, is that because of interaction of the laser with the gain medium or the amplifier. So it happens that whenever you have a higher intensity inside this amplifier region, you have the better chance of getting the light amplified. So if you increase the intensity in the amplifier region, that means the what we call this, the productivity, or the working performance of the amplifier will be better in compared to the flood case, but because in the flood case, since the laser is not particularly intensified at some region, the laser is at the same intensity at all of the region over here, there's a lower chance of getting amplified. Okay. So this is the reason that, one reason that some laser resonators just uses these curved mirrors in order to have a maximum intensity region inside the amplifier medium. So next is that if you have this laser light, the resonators that uses one of them at least curved mirrors, the question is, how can you correct the shape of the laser out of the box? I mean, how can you just make the output laser collimated? So there is only one chance to do this, is just use lenses. Okay, if you use the lens system like this, for example, two lenses, so that their focal point just coincides at this certain point, what you will have is that this uncollimated beam will get collimated after the second lens. So just you have a parallel laser beam. And even in the flat case, if you don't want the spot size of the laser this much, if you want to decrease the spot size, you can still use the mirrors, the lens system, so that you can change the size of or diameter of the output laser. You can always do this. And the other thing is that, for example, what you see in the last picture is that in addition to these two lenses, also they use some filter right at this focal point, equal. So the equivalent focals for both the lenses are at the same point. At this point, they use a filter, and so that you have a more homogeneous laser distribution, or the Gaussian laser distribution after the second lens. So also they use this to get a better or smoother laser output from the lasers.